we can now compute the moment. Compute the moment at point O using the what we call the cross product of this position vector and the force acted upon this body. So using the cross product, right? Okay, so the moment at point O, so always if we will gonna use this technique, the positive connotation is that using the right hand rule, so counterclockwise is the positive, so it only means that this rotation here is our positive rotation. Okay, so it is just for the purpose of reference. Okay, so the moment is just the cross product of the position vector RA cross our F, our force. So this RA cross F, and by doing that we can also write this in terms of this one, I, J, and K, and then our R I component is that we have positive 5, and then 2, then our K is just 0, right? Then for our F, we have this one, our force is, we have I component is 346.4, and then our J is negative 200, and then our K is just 0, right? Okay, so as you notice, our K part here is both 0, no? Since we are in 2 dimension, but the again the axis of rotation is at K direction, or at Z axis. Okay. So as you can see here, if we're gonna do our technique to find the I, J, and K for the moment, let me copy this. If we will gonna compute for say I component, then we're gonna cover this part and then do this part, right? 2 times 0 and 0 times negative 200, and as you can see, this is just equal to 0 because 2 times 0 is 0 minus 0 multiplied by negative 200 is just 0, so this part is just 0. And the same with the J component. Okay, since if we are gonna cover this part and do this, so you can see that the 5 times 0 is just 0, and 0 times this number is just 0, so our J is also 0. And okay, and what we have left here is the K component, right? So for our K component, we will gonna cover this part and do this pattern, right? So for our K, so our moment at K component is just 5 times negative 200, so we have 5 times negative 200 plus, minus 2 times 346.4, so this is K, right? So calculating this part, you can now have a negative 169 Newton. So this is moment at k directions. So it, it is correct, right, that uh, we only have the rotation effect at the k direction or at the z-axis, right? Because as we say that going back in our figure, if we have this kind of two-dimensional problem, x and y direction, then the force, the effect of this force causing the moment at this point O is that it will rotate at the z axis, right? So it is natural that in our computation, we have we only have the component or the moment at the k direction, or it says that the moment that it causes is about negative 1692.8 Newton. Okay, so since this is a negative sign, it only means that if this is our positive rotation, this is our positive direction, right? If our answer is negative, means that this force causes a inverse rotation based from our um, what do you call this? Based from this initial uh, positive direction. No, so since our answer is negative, then our rotation is against this positive rotation. So the moment that it causes is going to this direction at about 1692.8 Newton. Okay, so that is how we compute or determine the moment using the vector notation approach. Okay, so now in summary, let us recall what we have done to determine the moment caused by this 400 Newton force about point O using a vector notation approach. So first thing that we did is to, of course, we convert the given force into a vector notation form. Okay, so since we have a 400 Newton and this degree here, we can now easily find the I and J component of our force. Okay, so after that, we get the I component positive since it is going to the right direction, and since our Y component is going to the negative direction, so we have a negative 200J, right? And then to complete the I, J, and K, we add the K component, which is just 0, or we can directly show the I and J component only. Okay. Then after that, since our moment is about the force and the distance, so we need to determine what we call the position vector. So the position vector, we call it RA, and the position vector is from this point of rotation, point O, up to the position of your force. So that is the position vector RA. And the component I and J is, we have the 5 meters going to this and 2 meters upward. Okay, so we have both positive I and J, and we also add 0 to show the IJK component. But again, we can also omit the 0 part here, or the K part here. Okay, I just wrote the 0 part just to show you the cross product of when we gonna compute the moment at point 0, since we need the ijk to do the matrix, right? Okay, since to compute the moment, we use the cross product, so we have the vector position ra cross the force f, and we write it in this form and do the matrices. Okay, and if we have a two-dimensional problem, we can notice that the k component is 0. That's why if we gonna analyze it, the I and j component of our moment will gonna lead always to 0. Okay, and since the rotation is only about the z-axis, that's why we only have the k component of the result of our moment here. Okay, and by doing so, we found out that if we gonna do the pattern and compute the value, we have a negative value of our moment here. Since this is a negative value, it only means that the rotation it creates to the body, instead of going clockwise, I mean counterclockwise, the rotation is going to the opposite direction, which means we have a clockwise direction of moment with a 1692.8 Newton as the value. Okay, so all in all, this is our answer of the moment caused by the given force F at point O.